Today we'll start a new lesson, and after this lesson you will be able to answer this question. How can air hold up water? Do you think that air, which made from this very tiny gas or particle, can hold up any type of object? Do you think that air can hold up a water? And how that can be happen? So after this lesson you will answer this question. So the air around us is made from gas, and this air we cannot feel in this air when we walk or when we make or do any type of our activities. So what the meaning of air, or how this air can make a pressure? So today we'll understand the definition of pressure. And we talk about the pressure in the last lesson, but just as something change in an experiment. So we talk how we change the temperature and volume, and the pressure should be constant or something like that. But we don't understand what the meaning of pressure. Okay, so the pressure is an amount of force, and this force will be applied on an area, in a specific area, or an object surface. Okay, and we should understand the meaning of air pressure, and all that you can understand all that here. So again we will back here. I will use this command just for the pressure definition. Okay, you can see the particle. Okay, so I will add just amount of heat, just a little amount of heat here, and I want you to look at the movement of this particle. So this particle, okay, these particles move faster, and we have this kinetics energy, and we have a collision here, and we talk about the temperature. It's measure of the average kinetics energy that can be found inside this container. But we don't talk about the pressure. We have a change in pressure here, but why the pressure change? Why the pressure change? The heat is the same. We not change the heat. The pressure, the temperature is the same. We don't change the temperature, and the volume will not change yet. So we don't have any change in volume or in energy until now, and we don't have change in temperature. So what happened to the pressure? Why the pressure change? It's increase, decrease, increase, decrease. That because we have just one thing move here. We have this particle, and this particle is move, and we have a collision between this particle, and we have a two type of collision again. We have a collision between particle itself, and the collision between the particle and the wall of this container. So if you look here, this particle, okay, this particle have a collision between each other, and this particle is collide with each other and collide the wall of this container. So can you see this particle, how this particle collide all these container, all this area here, okay, all this area here collide by this particle. So we have a collision here between the particle inside the container and the wall of this container. We have this area here, all this area, okay, all this area is collided by the particle inside this container. So this collision between the particle and this area will make or applied a force in it. We have a force here. So this particle applied an amount of force, okay, on the in this surface area here, on all this area here, and here, and here, and here. So this particle, okay, applied force in all this area, and that called pressure. Okay, that called pressure. look at this particle. We have a collision between the particle and the wall of this container, and this particle applied a force on the surface area here and here and here, and that the meaning of pressure. So the pressure is a force that applied on the area of the surface of an object, and here the surface of an object is a wall of container. Okay, and that's why we have a change in pressure, because the amount of particle that collide the surface or the wall here of the container change. Okay, so that the meaning of pressure. So what the meaning of air pressure? Air pressure, we have here air pressure. So the air pressure is that force come from the collision between particle. So if this force is this force, okay, effect in this or applied in this area come from the collision between particle and the wall surface? If yes, we have an air pressure. So that's the meaning of air pressure. Okay, so here we understand the meaning of air pressure and the meaning of pressure. And before I start talk about air, I want you to watch this experiment. Not here. Yes, this experiment. We have a glass here and this card, and inside this glass we have a water, and look what happened. Can you see the water here? This water does not fall down, just stay inside the glass. Okay, we turn this glass upside down and it's not change. We not change. I just want to move to another slide. Okay, what happened here? Okay, so now we'll try to understand. I will clean up everything here. Okay, so now we'll try to understand everything about that. Okay, so we have a glass, okay, and we turn the glass upside down and this water will not fall down. Okay, so that a question, why this water will not fall down? Okay, so the question here is that why this water does not just fall down and just stay inside the glass. If I go here just a minute, yes, can you see this particle here? We talk about the pressure. So we have a particle and here we have an air. Yes, so we have a gas and we have a collision between this gas, and that means we will have a collision between the gas and not just a card here, no, between the air gas and the water molecules, or the water particle. Okay, between the water particle and water, yes, between the water particle and air particle. So what happened here is that this particle is collide this card and collide the water molecule here, or the water here, water particle, and that means we have this air pressure will push the card up and prevent the water to fall down. So inside this glass we have a gravity force, and the gravity force just try to make this water fall down as usual. And what happened here is this collision will come from the particle will prevent the water to fall down. So the air pressure will put the card up and keep the water inside the glass. Okay, so when I talk about the collision between the card and water and this air gas, that means I have a force applied in the surface here, and this force prevent the water to fall down, and this force is applied in this area. So when I have a force applied in the specific area, that means I have a pressure. So we have an pressure, so that's why I say I have an air pressure. So this air pressure will prevent this car to fall down, and then the water will stay inside the glass. Okay, so that why or how can air hold up water? So we answer this question now. So the air will not hold up water because it's heavier than water. Okay, but the air hold up water because we have a pressure, and the pressure or air pressure and come from the collision will hold up this water, and not air, just the word of air itself. No, we have an air pressure. The air pressure push the card up. Okay, so we have another experiment here. I hope this experiment will open or not, I don't know. So just a minute. Yes, look here. To this experiment. So we have this straw, and we have this cup. Yeah, what happened here? He put its finger here, and yes, when he removed its finger, the liquid fell down. So let's understand what happened here. So he take the straw and fill it with any type of liquid, and then he put its finger here, and in the end this liquid will stay or be found inside the straw and will not fall down. So why that happen? It's like the air hold up this liquid here. Again, the air will hold it or not, or we have an air pressure again. So what happened here, that when he put its finger here, he closed the side. Okay, so he prevent the pressure. So we have a pressure here. Okay, so we have a pressure again, and this pressure will apply in the force, applied force in this area. And when he put his finger here, he prevent this force to affect on the liquid inside this straw. So in the end, this liquid from the straw, or this liquid which found inside the straw, will not fall down. He will stay inside the straw. So in the end, all the liquid will just stay inside the straw until he remove his finger. So what happened here, if I will just try to remove everything, yes. Okay, and that why that happened? Look, the force of the air pressure in a bottom of the liquid is greater than the force of gravity. So here, why that happened? Because when he put its finger again, we have this air pressure and we have a force applied in this area, okay, and when he put his finger here, he prevents this force to affect in the liquid inside the straw. So this air pressure will not push the liquid down now. So we just have a gravity. So in the result we just have a gravity force, and this gravity force will try to make this liquid just fall down. But we have an air pressure now. We have an air pressure now, and this air pressure is try to prevent all this liquid to fall down. So what happened here? We have a collision here come from the air gas, and this particle of gas will collide the surface of this liquid. So what happened here, that we will have an force applied in this area. Okay, so all this area will have an force applied in it. Okay, so this is an area, and all this area will apply, this particle applied a force in this area, so that means we will have an air pressure. So this air pressure will push the liquid, and the liquid will be found inside this straw and will not fall down. Okay, so that's why the air will hold up this liquid, and this liquid will not fall down. Okay, so again for this fall here, can you see it? So why it's not just fall down inside the water? What happened here is the same as the straw and the gas or cup of water. So what happened here is that this fall have a particle inside it, and we will have a collision between the water and the air particle. So what happened here, that the air pressure prevent this ball to fall down inside the water, so that's why this ball here will stay in the surface of water and will not fall down inside it. So we finish. Yes, so I think that the lesson finished now, and I hope you understand the meaning of pressure. Okay, and I hope you understand this question, and I hope you to answer this question. Okay, see you in another lesson.